Let's read the docs. 3. An informal introduction to Python. In the following examples, input and output are distinguished by the presence or absence of prompts. 3 greater than signs in a row, or 3 periods in a row. To repeat the example, you must type everything after the prompt when the prompt appears. Lines that do not begin with a prompt are output from the interpreter. Note that a secondary prompt on a line by itself, that is the 3 dots in a row is the secondary prompt, in an example means you must type a blank line. This is used to end a multi-line command. You can toggle the display of prompts and output by clicking on the primary prompt in the upper right corner of an example box. If you hide the prompts and output for an example, then you can easily copy and paste the input lines into your interpreter. Many of the examples in this manual, even those entered at the interactive prompt, include comments. Comments in Python start with the hash character, hash, or pound sign, and extend to the end of the physical line. A comment may appear at the start of a line or following whitespace or code, but not within a string literal. A hash character within a string literal is just a hash character. Since comments are to clarify code and are not interpreted by Python, they may be omitted when typing in examples. Some examples. This here is the first comment, as indicated by the hash character in front of it. Here we've got the variable spam we have set to the value of the integer 1. But even though there is code on this line that the computer will read, because it meets this hash character here, the rest of it will be counted as a comment. And even when this user pressed enter and some white space, they made a whole nother, this is another comment that will also not bother the interpreter. But here we set the variable text equal to the value of this string, as indicated by these quotation marks. And because this is a string, the hash character inside is just treated as a letter or a character. Using Python as a calculator. Let's try some simple Python commands. Start the interpreter and wait for the primary prompt. It shouldn't take long. The interpreter acts as a simple calculator. You can type an expression at it and it will write the value. Expression syntax is straightforward. The operators plus, minus, asterisk, and / can be used to perform arithmetic. Parentheses can be used for grouping. For example, here it would be like the user typed in 2 plus 2, and when they pressed enter, they got the output of 4. Here, 50 minus 5 star 6 is equal to 50 minus 5 times 6, 20. And here, just like in a regular arithmetic, because this is cordoned off in a parenthetical statement, the interpreter will evaluate that first and then do the rest of the arithmetic. So this is 50 minus 5 times 6, and then the evaluation of that is what is then divided by 4, resulting in 5.0. And even though it is a whole number, as it says here, division always returns a floating point number, which is a number with a decimal point. Don't ask me, man. 8/5, once again, see 1.6. The integer numbers, exempli grazia 2, 4, 20, have type int. The ones with a fractional part, e.g. 5.0, 1.6, have type float. We will see more about numeric types later in the tutorial. Division, / always returns a float. To do floor division and get an integer result, you can use the // operator. To calculate the remainder, you can use modulo, or what you might recognize as the percentage sign elsewhere. So, in another example, 17 / 3 results in 5.666. 17 / 3, 17 floor division, or 17 floor divided by 3. I'm not really sure how to say that. This discards the fractional part, all of this, so you only get back the whole number, 5. 17 modulo 3 would get you the remainder that would be left over after floor division. And 5 * 3 plus 2, I don't know why they included that in the example, because that's just more regular arithmetic. With Python, it is possible to use the * operator to calculate powers. 5 * 2 is 5 squared, 2 * 7 is 2 to the power of 7. Simple as. The equal sign is used to assign a value to a variable. Afterwards, no result is displayed before the next interactive prompt. So here in this example, the variable width is set to the value 20, variable height is set to the value of 5 times 9. And crucially, it will evaluate that arithmetic, and so it's not going to spit out 5 star 9 any time that you want to print height. It will spit out 45, the result of 5 times 9, right? So now width and height, these words for the rest of the code, will be treated exactly as if they are these number values. And so, therefore, you can operate on them with all of the basic arithmetic operators just like they were numbers. Width star height is equal to 20 times 45, resulting in 900. 45 is 5 times 9, right? Yeah, okay. If a variable is not defined, that is assigned a value, trying to use it will give you an error. So here, this bizarre user just typed in into the interpreter and just hit enter because they're trying to feel. You get this traceback thing on everything, on every error. It'll tell you what file you're in and what line you're in. And then here we get the specific error that this represents, a name error, because you try to call a variable that hasn't been defined. There is full support for floating point. Operators with mixed type operands convert the integer operand to floating point. So in this example, 4 star 3.75 minus 1 will return 14.0, a float, even though it is a whole number that could be represented in an integer, because once you mix them up, the default has to become a float in order for the computer not to freak out. In interactive mode, the last printed expression is assigned to the variable underscore. This means that when you are using Python as a desk calculator, it is somewhat easier to continue calculations. For example, here we set the value of this variable tax equal to the result of 12.5 divided by 100, set the variable price equal to the value of 100.5, multiply price times tax, we get 12.5625. Now, 12.5625 being the last thing that was printed, then we can use this little placeholder variable underscore in place of it. And price plus underscore is going to be 100.5 plus this. And now we're calling the round function on that underscore, that same underscore, and we're rounding it to the to 2 decimal places. Because this was just printed, now underscore means this. And so we are rounding the number 113.0625 to 2 decimal places, thus giving us 113.06. This variable should be treated as read-only by the user. Don't explicitly assign a value to it. You would create an independent local variable with the same name masking the built-in variable with its magic behavior. In addition to int and float, Python supports other types of numbers, such as decimal and fraction. Python also has built-in support for complex numbers and uses the J or capital J suffix to indicate the imaginary part, e.g. 3 plus 5j. Text. Python can manipulate text, represented by type str, so-called strings, as well as numbers. This includes characters, such as the exclamation point, words, such as rabbit, names, such as Paris, and sentences, such as got your back, etc. Yay. They can be enclosed in single quotes or double quotes with the same result, as long as it is the same on each side of the string. So here we have spam egg, single quotes.
Yep.
Paris rabbit got your back, yay, in double quotes.
Yep.
And 1975, these, despite being digits that would be treated as integers elsewhere, being flanked as they are with these quotes, remember, are now a string. To quote a quote, we need to escape it by preceding it with backslash. Alternatively, we can use the other type of quotation marks. So here in this example, doesn't is a word that contains a single apostrophe, and therefore is going to be thrown off. It's going to throw off the interpreter because it will think that only this in between the first 2 quotation marks that it finds is the string. Unless we put this backslash here, then it will know to ignore the quotation mark directly after the backslash and wait, look for another one. So when we type doesn't with this backslash, and it will print the regular word doesn't, okay? Or we could just use double quotes to indicate the string, and if we use double quotes indicating the string, then single quotes inside the string will be ignored. And here are just beating that horse even further. In the Python shell, the string definition and output string can look different. The print function produces a more readable output by omitting the enclosing quotes and by printing escaped and special characters. So, here we set the variable s equal to this value of the string, which, as you can see, contains this \n thrown in there in the middle. The hail, that's called the new line character. It means new line. Now, if we just type s and hit enter into the interpreter, then it will show us what that variable is. It'll show us that string without kind of taking that formatting instruction that we provided in it. But if we call the function print on that variable, then it will actually interpret this and format it accordingly, and thus create this, where you got a first line and a second line. I can't imagine a situation where you would need to tell the interpreter just to show you the variable anyway without using print, so it's not going to be... If you don't want characters prefaced by \, to be interpreted as special characters, you can use raw strings by adding an R before the first quote. So, like for instance, this person is for some reason trying to print a file path, and there's so many dang backslashes in here, and an in. It's going to throw everything off. So you just put an R in front of the string inside the little parenthetical statement that is passed in as an argument to the function print. And you'll hear about those terms later. Just remember, put the R in front of the string, and then you'll actually get the way it literally looks instead of being thrown off. There is one subtle aspect to raw strings. A raw string may not end in an odd number of \/ characters. See the FAQ entry for more information and workarounds. It may not end in an odd number. I guess that makes sense. Yeah, because then it would have one over. String literals can span multiple lines, and one way of doing that, of allowing them to span multiple lines, is by using triple quotes. As long as there's 3 of these on either side, they can be single or double yet again. End of lines are automatically included in the string, but it's possible to prevent this by adding a \/ at the end of the line. The following example, which is just a joy to look at that thing, produces the following output. Note that this initial new line, see that they started typing here and then would have pressed enter to be a new line, that's not shown at all here. Strings can be concatenated, and for some reason here they say glued together, but they could have just said chained together, because that's what concatenated means. It's from Latin con and catenare, to together chain. So to concatenate literally means to chain together, but glued together, even though chained together, with the plus operator, and repeated with a star. So here, 3, the integer 3, star, the string un, and then the plus sign, and the string ium, is going to actually multiply un 3 times, and you'll get 3 copies of this string, and then it will stick it together like links in a chain, stick it together with ium, and you will literally get this, unium. And it's magic that it can do that so simply and easily. 2 more string literals, i.e. the ones enclosed between quotes next to each other, are automatically concatenated. Strings tangle up automatically together when you put them next to each other in your pocket. Strings love each other. So you put string pi space and the string thon, and the output will just be Python. This feature is particularly useful when you want to break long strings. So say here we've got the variable text set equal to the value of this parenthetical statement in which there are these 2 strings that span 2 lines. Put several strings within parentheses to have them join together. And if we call that variable, see, it is done. Quick little note, see how there's this extra bit of white space before the first closing quotation mark? That is included intentionally, or else whenever it's the strings are concatenated and displayed, the parentheses and 2 would just be stuck together. So remember to put a space either at the very end of the first one or the beginning of the next thing that you're trying to concatenate. This only works with two literals, though, not with variables or expressions. So here we've got the variable prefix set equal to the value of pi, prefix thon. Typing it like we tried to concatenate these two strings, if we try to do that with a variable set to the value of a string and a string literal, it won't work. Because that first string has, they've been converted. They now have a different religion, and they just can't get along anymore. Let's see, this is what it's telling you, a syntax error. And if you try it again, you'll also get a syntax error. The first thing that you should learn is that you probably shouldn't just repeatedly try the exact same thing. You will probably get the same syntax error. If you want to concatenate variables or a variable and a literal, use the plus sign. Okay, it's not that hard. You just can't. They need a little bit of help. So you see, prefix, which we set earlier to the value of the string pi, plus the string literal thon. This will produce Python for us. Nice and easy. Easy peasy, lemon squeezy. Strings can be indexed, subscripted, with the first character having index 0. And by indexed, that means every character in the string, you can think of it as like a position in a list that starts at 0 and counts up infinitely for as many characters are in the string. Each one has their own specific little spot in the list, and that's what to index them. And in Python, it's 0 indexed, meaning every time that you see that and you're counting the indices or something, it will start at 0. There is no separate character type. A character is simply a string of size 1. So, say we've set the variable word equal to the value of the string literal Python. If we type word and then in square brackets type the number 0, this means look at the character in the 0th position in the index, or in the list, the array. The 0th array. 0th index. Which would be P. And word, square brackets 5, would be at index 5. But remember, don't confuse that with position 5. I think that saying character in position 5 is kind of misleading, because index 0 is what I would think of as position 1. Anyway, indices may also be negative numbers to start counting from the right. So word, and then in square brackets, -1. This will just go all the way back around. You'll get the very last character, no matter how many indices are in the string, no matter how many characters in the string. -2, get the second to last. -6, you'll get the 6th to last, and since this is a 6-character string, it returns P in this case. Note that since -0 is the same as 0, negative indices start from -1. Just like a number line, everything is mirrored except for 0. In addition to indexing, slicing is also supported. While indexing is used to obtain individual characters, slicing allows you to obtain a substring, a series of characters within the larger string. So word, square brackets, 0:2 is a slice, getting the characters from position 0 inclusive to 2 exclusive. And the slice will actually make a copy and return a new sort of copy that is a smaller piece of this original thing that remains unchanged. You'll get pi back in this case. In a word, 2:5, characters from position 2 inclusive. You start at 2, and 2, 3, 4, and when you see 5, you stop. Always that first number is in the substring. The second number, think of it like that's the boundary, the wall. It's not in your string, that's just where you stop. Slice indices have useful defaults. An omitted first index defaults to 0. An omitted second index defaults to the size of the string being sliced. So word in square brackets :2 is character from the beginning to position 2 excluded. Again, pi. So this is exactly equivalent to this. You don't ever have to type 0 in this case. Word 4:, means characters from position 4 to the end. And so keep an eye on where the colon is, that the order of that. If it's in front, that means you're starting at the beginning of the word and going to some number. If it's after the number, it means you're starting at that index and going to the end. Word -2, colon, is characters from the second last, again inclusive, to the end. And note how the start is always included and the end always excluded. This makes sure that S:(I) plus SI:, is always equal to S. In this case, you wouldn't end up with a duplicate of I, because here the I isn't included and here it is. So you'd be able to say word :2 plus word 2 : and it would return just the entire original word. Same with any other index you chose, as long as it's within the limit. One way to remember how slices work is to think of the indices as pointing between characters, with the left edge of the first character numbered 0. Then the right edge of the last character of a string of n characters has index n, for example. The first row of numbers gives the position of the indices 0 through 6 in the string. The second row gives the corresponding negative indices. The slice from I to j consists of all characters between the edges labeled I and j, respectively. So to slice from slice 1, 5, you see you start at 1 and you have the thing that's in position 1, and you go all the way until you reach 5, meaning you don't have this letter associated with 5, and you would just have these 4 letters. Okay. For non-negative indices, the length of a slice is the difference of the indices, if both are within bounds. For example, the length of word 1:3 is 2. Attempting to use an index that is too large will result in an error. Specifically an index error. So you're reaching for a string index that's out of range. However, out of range slice indexes are handled gracefully when used for slicing. So say we tell the interpreter word 4:42, because programmers are really nerdy and they just cannot help but make Monty Python references and put 42 everywhere and everything. There's word 4:42 would return on, and word 42 to the end, colon, would return nothing, because there's nothing out there to go after. But in this case, it will start at 4, include 4, and just go all the rest that it can. It just gives us ON. There's nothing else after that, but it'll still give us that. So Python strings cannot be changed. This is kind of interesting, and there's some of the... you might think that they could, but any time that you change them or modify them, you're really just like returning a new copy or something, a modified copy. They are immutable. Therefore, assigning to an indexed position in the string results in an error. So if we try and select the 0th index in Word and update the value of that index to a new character, a new string, it'll say it can't do that. String object does not support item assignment. And then if we try the exact same thing again, we will get the same error. If you needed this tutorial to teach you about that concept, you might need to start at something a little bit more elementary. If you need a different string, you should create a new one. J plus word 1 : will produce Jython. It's like a rich person's kid. Word : 2 plus pi would result in pi. The built-in function len, though I'll read it out loud as length from here on, len returns the length of a string. So we've got the variable s set equal to the value of the string supercalifragilisticexpialidocious, and once we have set the value of that variable s to that string, if we call the len function on it, it will return how many characters are in this. See also other parts of the tutorial. We will get there. 3.13 lists. Python knows a number of compound data types used to group together other values. the most versatile is the list, which can be written as a list of comma-separated values, which is, by the way, what CSV stands for. I didn't know that until recently. List of comma-separated values, items between square brackets. Lists might contain items of different types, but usually the items all have the same type. So, for instance, say we had this list. Just read when I'm doing this. You don't need me to do all the work for you. Alright, so say we had this list here. If setting the variable squares equal to the value of this list, as indicated by square brackets, and a series of items separated by commas. Now, squares will return that list. Like strings and all other built-in sequence types, lists can be indexed and sliced. So, squares at the 0th index, calling that, will return this first item in the list. Squares -1 will be the last, so it will return 25. And note, so not just 5. Remember, like in this case, each of these numbers is its whole discrete unit. So -1 will return 25. Squares -3, colon, will return a whole new list, just the one, a new list that contains only the items that were found by slicing this list, right? Lists also support operations like concatenation. So squares, the list we defined earlier, plus this new list here, will result in all the values in order in the first list, followed by all the values in order in the second list, put together between one set of square brackets in its own new list. Chained together. Unlike strings, which are immutable, lists are a mutable type, i.e. it is possible to change their content. So say we had cubes, set that equal to this list here. A comment says something's wrong here. Next we ask the interpreter, what's 4 to the 3rd power? 64. Son of a gun. We screwed up the list. We can fix that by calling the 3rd index in that list and updating the value to 64. Now when we call the same list, look at that. We don't look like an idiot anymore. You can also add new items at the end of the list by using the list.append method. We will see more about methods later. So cubes.append with 216 passed in will add the cube of 6. It will add 216 to the end of the list. Cubes.append 7 * 3 will put in the cube of 7. Again, it will evaluate that and give the result and add that to the end of the list. So now we call the list again. See, we've got the new value and the new value that is the result of the arithmetic operation that we described in the parenthetical statement here. It's called an argument, but since you'll hear about that. Simple assignment in Python never copies data. When you assign a list to a variable, the variable refers to the existing list. Any changes you make to the list through one variable will be seen through all other variables that transfer to it. So you're not, if you're updating a different variable with that list here, RGB. We're setting RGB equal to this list, red, green, blue. Now if we define a new variable, RGBA, and update its value equal to this one, we have not actually made a copy of the list in this instance. We have just made 2 different ways to get to the same list. We could call RGB or we could call RGBA. These are 2 doors leading into the same stairwell. Ladder to heaven. So if we call the ID function on RGB and we ask to evaluate, is this evaluate to true? That these 2 things are equal? Yes, it is true. And if we append something to RGBA, or by typing RGBA.append, and then add the string alf, then we call RGB, that original list, we will see that change that we performed on RGBA will be reflected in RGB, because they both just point to the same thing. All slice operations return a new list containing the requested elements. This means that the following slice returns a shallow copy of the list. Correct underscore RGBA, this new variable, we're setting that equal to the value of RGBA, that list, sliced, and it's just a colon. It's like a slice that contains the whole thing. It's like if you pick up a cake and you say, yeah, I did take a slice of the cake. It just happened to be the entire cake-sized slice. And that's what this means. It's a shallow copy, right? So correct underscore RGBA -1, the last index in this new list that is a shallow copy. If we update the value of that last index to this new string alpha, now we've got two separate things. Now when we call correct RGBA, we see the fixed version that has alpha in the end. But if we called RGBA again, we see that he has not yet learned his lesson at all. Assignment to slices is also possible, and this can even change the size of the list or clear it entirely. So if we set the value of the variable letters equal to this list A, B, C, D, E, F, and G, and then we call letters, see it, replace some values, go letters, we take a slice from the second index inclusive up to but not including the fifth, and we will update the value of those specific indices to this series of strings, C, D, and E in capitals. Now we check the same list again and look, our changes have been reflected. Now remove them. You can remove them by selecting that slice and simply updating it to what this is just an empty list. If you just have two square brackets with nothing in them, then you will still create a list object, and you can still update something with it. It's just empty. So now we see that they're just gone. Now clear the list by replacing all the elements with an empty list. As we saw earlier, here we are taking with a single colon and nothing else inside the square brackets. That is the slice of the cake. That's the slice of cake that contains the entire cake. And we are setting that equal to an empty list. It means that when we call letters anytime in the future, it's lost all meaning for its existence. It's empty. There are no fucking letters in there. Okay, the built-in function len, length, also applies to lists. So letters, see that? We gave it back its letters. Now when we call the len function on it, we see 4. Now it is possible to nest lists. We can create lists containing other lists. Workflowy anybody? For example, say we've got A here set to the value of this list containing A, B, and C. And we've set in equal to a list containing 1, 2, and 3. We set X equal to a list containing A and N. Now if we call X... Oh, right, yeah. Sorry, I was moving too fast. I almost missed this myself. We have made X is equal to a list containing this variable and then this variable. So this list and then this list. And it will show up that way when we call X. It's just this whole ass list is in this spot, then comma, space, and then this whole ass list. And this list still will be considered as a list that contains only 2 spots. Right? So we call X0 the 0th index or first spot, and it will return that whole ass list that was A. And if we call X 0, 1, that's how we go deeper into the nesting. So this is saying that the whatever is at the 0th index of X, and then what is at the first index of that thing at the 0th index of X. So we're at the 0th index of X is this whole ass list, and then in this whole ass list at the first index is not A, but this B. And that's what we get. Bada bing bong bong. First steps toward programming. Towards. Of course we can use Python for more complicated tasks than adding 2 and 2 together. For instance, we can write an initial subsequence of the Fibonacci series as follows. So, we just got comments. The Fibonacci series, the sum of two elements defines the next. If you gotta know what the Fibonacci series is if you're watching this niche shit. So A, comma, B equals 0, comma, 1. What this means, you are declaring two variables at once and assigning values to each of them at the same time. And the values assigned to them, they will be assigned in the order respectively that they were written. So A is being set to the value of 0, B is being set to the value of 1. And this will happen simultaneously, right? Now, a while loop. While A is less than 10, print A comma B equals B comma A plus B, means that it will iterate through, it will check A, it will say, what is the value of A? Is it less than 10? If so, then I will print out A. And then after I print out the value that A currently is, I will update the value of A to be the value of B, and I'll update the value of B to be the result of adding together A plus B. And because it does this all, it'll swap them out simultaneously. So that means if we start with the values of 0 on A and 1 on B, then you see this while loop will check, it will print A, okay, and then update the values, it'll go again, and then it will print 1, 2, 3, 5, 8, with each step doing this swapping out. I realize I probably don't need to explain that in any greater detail than that. You probably get it. If you don't, pause the video. This example introduces several new features. The first line contains a multiple assignment. The variables A and B simultaneously get the new values 0 and 1. On the last line, this is used again, demonstrating that the expressions on the right-hand side are all evaluated first before any of the assignments take place. The right-hand side expressions are evaluated from the left to the right. Which is why it wouldn't, this wouldn't make sense otherwise, right? It'd be a paradox. That's why it's important sometimes to do this simultaneous swap. The while loop executes as long as the condition remains true. The condition being A is less than 10. In Python, like in C, any non-zero integer value is true. 0 is false. The condition may also be a string or list value. In fact, any sequence, anything with a non-zero length is considered true. I didn't realize how far I was getting out of frame. Let's see. In fact, any sequence, anything with a non-zero length is true. Empty sequences are false. The test used in the example is a simple comparison. The standard comparison operators are written the same as in C. The left-pointing chevron is less than, the right-pointing chevron is greater than, equal sign is equal to. We've got less than or equal to, greater than or equal to, and the only one that is maybe not entirely intuitive is the bang equal, or the exclamation point equal sign is not equal. So, in normal arithmetic, you might write an equal sign / equal sign. In Python, you would write exclamation point equal sign. The body of the loop is indented. Indentation is Python's way of grouping statements. At the interactive prompt, you have to type a tab or spaces for each indented line. In practice, you will prepare more complicated input for Python with a text editor. All decent text editors have an auto-indent facility. When a compound statement is entered interactively, it must be followed by a blank line to indicate completion, since the parser cannot guess when you have typed the last line. And it's rude to assume that it can. Note that each line within a basic block must be indented by the same amount. That a computer knows that you're trying to group things together if they all line up vertically. And if they don't line up vertically, it will tell you that there's something wrong. The print function writes the value of the arguments it is given. And the argument is, this will be explained in more detail, but I'll go ahead and say the argument is what is passed in to the function in the parenthetical statement. So just whatever you have right here, that's, these are two arguments passed into the print function. The print function writes the value of the arguments it is given. It differs from just writing the expression you want to write, as we did earlier in the calculator examples, in the way it handles multiple arguments, floating point, quantities, and strings. Strings are printed without quotes, and a space is inserted between items, so you can format things nicely like this. So say we set the variable I equal to the value of 256 times 256. When we pass in the two arguments to print, first the string the value of I is, and then a comma, and then the variable I, it will print out the value of I is 65,536. The keyword argument end can be used to avoid the new line after the output, or into the output with a different string. So here we see the simultaneous swapping thing again. A comma B now equals 0 comma 1, respectively. And while A is less than 1,000, print A followed by end equaling this comma. And then update the value of A and B simultaneously with the values B and A plus B, respectively. And this means that it will not just, in each iteration of the loop, it will print A and it will end it out with this comma. Footnote, since star star has higher precedence than minus, if you type something like -3 star star 2, it will be interpreted as if the 3 star star 2 is its own parenthetical statement with the negative, that minus sign applied to all of it. And thus it would result in -9. So to avoid this and get 9, you should put the -3 in parentheses and then set that to the power of 2 using star star. And unlike other languages, special characters such as \n, which is just called new line, have the same meaning with both single and double quotes. The only difference between the two is that within single quotes you don't need to escape double quotes, but you have to escape single quotes, and vice versa. Or vice versa if you just hate humanity and Latin.